In the pharmaceutical analysis, many analytical techniques are used. Each analytical technique has the specific use and application. Out of those analytical techniques, hot stage microscopy HSM is used in the pharmaceutical industry, and it has wide application in the formulation R&D as well as in the API analysis. Hot stage microscopy, as the name indicates, it involves the use of heat, and it studies how heat affects the material or API under the microscope. The changes are observed. So, understanding thermal behavior of the material under microscope at a microscale is the main function or principle of the HSM. HSM is a technique that combines optical microscopy with the heating stage to observe sample behavior under controlled temperature conditions. You can go on increasing the temperature or changing the temperature, and you can study how it is going to affect the material. HSM is used for studying physical changes such as melting, crystallization, solid-solid transitions, and polymorphic changes. Principle of hot stage microscopy. So, sample is placed on a microscope stage with a controlled heating and cooling system. The system heats the sample while visual changes are observed and are recorded. It can be paired with polarized light to observe the crystalline versus amorphous transitions. So now you might have heard regarding the crystalline and amorphous transitions. So whenever heat is supplied to the material behaves as per its nature, whether the material has specific form or specific crystalline form, or it is amorphous in nature. So the behavior under the heat is specific property of the substance, and those properties are studied. Key components of the HSM are hot stage unit, optical microscope, temperature controller, digital camera and software for the image capture and recording of the image, sample holders or slides. Now we'll see the applications in the formulation R&D. Polymorphism studies are done, melting point determination, amorphous crystalline transitions, study of the compatibility, co-crystal screening, and salt formation studies. These are the applications of HSM. Polymorphism studies identify and distinguish between different crystalline forms. Melting point determination, observe precise melting behavior visually. Amorphous crystalline transitions, track recrystallization of amorphous API. Compatibility studies, API excipient interactions under the thermal stress. Co-crystal screening, visualize new solid forms during heating, and the salt formation studies. So based on the requirement, based on the study objective, the HSM technique can be used. This is a hypothetical case study for API polymorphism. Objective of the study by using HSM was to identify stable polymorph of the API. The polymorphs were studied using HSM. Form 1 melts at 135 degrees Celsius. Form 2 melts at 140 degrees Celsius with polymorphic transition at 140. What is the outcome? So HSM helps in choosing the thermodynamically stable form for the formulation. We can screen the polymorphic form by using HSM. Advantages of HSM: real-time visualization, small sample requirement is there, rapid thermal profiling can be done, it combines visual and thermal data, and it is useful in early stage R&D and reformulation studies. Now, what are the limitations? So, limited to optical visible changes, it requires expert interpretation because it is a qualitative type of technique. So, repeatedly the HSM should be used, the sample should be analyzed, and it requires expert interpretation. It is not suitable for all the materials. It is qualitative rather than quantitative. Complementary techniques: DSC, that is differential scanning colorimetry. These are the complementary techniques for the HSM, XRD, TGA, FTIR, and DVS. So along with the HSM, if complementary techniques are used, then it will be advantageous to have the particular data and interpretation for the study. Hot stage microscopy is a powerful visual tool for understanding the thermal behavior of the pharmaceutical substances, and it plays important role in polymorph screening, doing the compatibility studies, and in polymorphism. Also, it is used in the reformulation. When it is combined with the other techniques like DSC, XRD, TGA, TIR, DVS, it can support robust formulation development. Compared to all the techniques, this technique is utilized to understand the thermal behavior of the material. This is the information regarding hot stage microscopy. The principle is observing the material under the effect of heat and then correlating these changes with its nature. Let's meet soon with such kind of informative video. I request you to do like, share and subscribe to this channel. Share these channel videos to your friends and colleagues. Thank you.